In your flying experiences, you will find that the occluded front has the characteristics of both the cold and warm fronts. In this film, we'll see the development of the occluded front, how it forms, and its associated weather. On the surface weather map, an occluded front is shown by a solid purple line. The classical pattern for the development of an occluded front begins with the formation of an open wave. This open wave occurs when a low pressure center or cyclone forms along an existing front. As the wind in the northwestern part of the low center becomes more northerly, the movement of the cold air is accelerated and the cold front bulges southward. As a result of the cyclonic circulation in the eastern part of the low pressure area, the cold air retreats and is replaced by warmer air, causing this portion of the front to become a warm front. This configuration of the cold front and the warm front establishes the open wave. Cold air lies next to the surface north of the wave, whereas south of the wave, in the warm sector, warm air is in contact with the ground. Let's examine the two fronts in cross-section. Along this line, the frontal surfaces slope over the cold air. The accelerated cold air causes rapid lifting of the warmer air, producing a narrow, violent weather band along the cold front. Along the warm front, the warm air rides gently over the cold air, producing a widespread area of non-violent weather in advance of the front on the surface. Depending upon the nature and temperature of the terrain, this air in the warm sector will be stable or unstable. Now, with this open wave established, let's see how an occluded front is formed. Generally, the cold front moves more rapidly than the warm front. When the cold front overtakes the warm front, the wave occludes. An open wave does not always develop into an occluded front, but when it does, you should be thoroughly familiar with the weather it produces. The occluded front may develop in one of two ways, depending upon the temperature of the air beneath the cold front and the temperature of the air beneath the warm front. Here is an example showing the development of a warm front type occlusion, the type most frequently found on the west coast during the winter. The circulation around the low pressure area draws polar air from the Pacific in under the cold front and also draws polar air from Canada in under the warm front. Since land areas are colder than adjacent water areas in winter, the polar air from Canada under the warm front will be colder than the polar air from the Pacific under the cold front. As the cold front overtakes the warm front, the cool Pacific air rides over the cold Canadian air. The cold front rides up and over the warm front, becoming an upper front. This is a warm front type occlusion. Remember, whenever the air under the warm front is the coldest of the air masses involved, a warm front type occlusion occurs. Another point to remember is that a warm front type occlusion produces an upper cold front that may ride out well in advance of the occlusion at the surface. The surface weather map shows this type occlusion with a solid purple line, an extension of the warm front. The upper cold front is shown with a broken blue line, usually well in advance of the occlusion. The winds around the occluded front tend to follow the pattern of the isobars. The second type of occluded front is the cold front type occlusion. This is typical of the East Coast in winter. Here, the circulation around the low draws the colder air from Canada in and under the cold front, while the cool air from the Atlantic flows in under the warm front. The cold front, with its colder Canadian air, overtakes the warm front with its cool Atlantic air and forces it aloft. The front aloft in this situation is a warm front. This is a cold front type occlusion. It forms when the coldest of the air masses is under the cold front. The position of the upper warm front is very close to the occlusion at the surface. The map shows the cold front type occlusion as a purple line, but now an extension of the cold front. If the upper front is shown, it is depicted with a broken red line. The winds about this occlusion will also follow the pattern of the isobars. Simply stated now, the warm front type occlusion has its upper cold front, and the cold front type occlusion has its upper warm front. The weather resulting with either of these is varied. You should understand, however, that certain characteristics are common to both type occlusions. In each case, the occlusion is a combination of a warm and a cold front and has weather characteristics typical of both. The weather typical of the cold front, that is, the narrow, violent weather core extending to great heights, is generally found along the upper front in both the cold front type and the warm front type occlusion. The occlusion also produces widespread layers of clouds typical of the warm front. In either case, violent weather should be anticipated. When occlusions are indicated, be extremely cautious in your flight planning, because the great cloud layers they produce may hide from view the violent weather along the upper fronts. Unexpected contact with this weather is always a dangerous probability. In both types of occlusions, the warm air is lifted rapidly along the part of the upper front, closest to the warm sector. You must carefully study the weather at the point of occlusion and for distances as great as 100 miles along the upper front, for it is here that the most violent weather associated with the occluded front will generally be encountered. The weather conditions in either the warm or cold front type occlusion can be violent and widespread. With experience, your conclusion will be that each situation must be studied carefully and discussed with the forecaster to properly plan for flying through an occluded front. All weather facilities, plus the experience of trained personnel, are provided for you. Your personal safety and your Air Force mission effectiveness are the end products.